Hello everyone, welcome to my channel once again after a very long days. As most of you have requested me to do the video regarding the spirometer, so I have started it and I have tried a lot to reach you. Thank you for your love and support. So now let's discuss what is spirometer. So as I have already told you in my previous videos, first of all, what is the aim of the experiment? So the aim of the experiment is to measure the radius of curvature of a spherical surface. So it can be convex, a spherical surface can be convex or concave, by using spirometer. So now the second one is how to do the experiment. So the apparatus that is required is, of course, apparatus required here is the spirometer and the watch glass. Why watch glass? You can see here, these are the watch glass, because this has a surface, either concave spherical surface or convex. This is your convex spherical surface and this side is your concave spherical surface. You can see here. So this is the watch glass I am taking, and this one is the spirometer. All of you can see, this is your spirometer. So first of all, as I have told you earlier also, after this you are going to write the theory, but I am not going into that. Before handling any instrument, as I have told you earlier also, you need to first calculate the list count. So we will directly go to the observations, and in observation what we are going to do, we are going to calculate the list count of spirometer. So this is the spirometer. So now as you can see here, let me just first tell something about the spirometer. You can see a scale over here. This one is the main scale. This is, you can see here it is written 0, 10. You can see here it's written 0, 10 and 10, and you can see the divisions over here. From 0 to 10 there are 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also 10, here also 10. Now this one is the circular scale. You can see here, this is my circular scale, and this is 0 and 10, 20, here it's 30, 40, 50, 60, 70, 80, 90, and the 0 is coinciding with the 100. And it has 4 legs, you can see. These are the 3 legs present over here, and this is the middle one. I will gradually tell you what is the use of this one. But first of all, we are going to calculate the list count of this spirometer. For that, you are going to write it in observation. So let's go and write the observation. So here is the observation. I am omitting some of the steps while writing the practical. You are going to write it in order. So first one is calculation of list count. You see, first what you will going to do, you have to take this one, and you see this one is rotating. So you take this, circulate this screw by holding it from here and keep it, the A's of this one must coincide with the 0. You see, it's coinciding. Now give 5 rotations to the circular scale. Now I am rotating, you see, give 5 rotations to the circular scale. Now it's at the A's. How you are going to rotate? You have to mark the reading from the circular scale. Now you see, I am marking the reading from the circular scale, and what is my reading? You see here, the reading is, this age is my reference point, so this is 50, this is 51, 52 and this is 53, as you can see here. This is my 53, reading is 53, because here it is 60. See here, 50, 51, 52 and it's 53. So I have to circulate, give rotations in such a manner that the 53 has to be completed. Okay, I hope so this is clear. So now circulate, suppose I am circulating, give 5 rotations. So let me give 1 rotations. So 1 rotation complete. 2 rotations complete because I have crossed 53. 3 rotations complete. 4 rotations complete. And here I am going to cross 53. So 5 rotations complete. Now I am just taking it to this side. You see what I am telling. Now all of you try to understand. As I have given 5 rotations to the circular scale, now what is the distance moved in the main scale? You see, I have started from 0. So now it's at this age. So I have completed how many millimeter? This is 5 millimeter. You can give clockwise as well as anti-clockwise rotation. There is no need of thinking that in which side I will rotate. So you can give any rotations because I am just measuring how much distance it is completing in a main scale. You see, by giving 5 complete rotations, the distance moved is 5 millimeter. Here it is 5. This is 0. This one is 5 because here it is 10. So let's write down our observation. So the way I have done it earlier for screw gauge. So by giving 5 complete rotations to the circular scale, distance moved in the main scale is 5 millimeter. So by giving 1 rotations, this will be equals to 5 divided by 5. So which is nothing but 1 millimeter, which is nothing but 0.1 centimeter. Now how to calculate list count? The same formula here it is also applicable. The way we have calculated for screw gauge, as all of you have seen it in the previous videos. So list count formula is pitch divided by number of divisions on the circular scale. CS means circular scale. What is pitch? As I have already told you earlier also, pitch is nothing but this one, the one you have calculated. That means by giving 1 rotation, by giving only 1 rotation, we are advancing only 1 thread in this screw. So if we are advancing only 1 thread, what is the distance moved in this main scale? Is nothing but the pitch. So pitch is here, the pitch is how much? The pitch is 0.1 divided by how many divisions are there in the circular scale. As I have told you earlier also, the divisions present in the circular scale is 100 because here 0, here 90 and after 90 we have 100 coinciding with 0. So 100 divisions are there in the circular scale. So divided by 100. So what we are getting? 0.001 centimeter. So this is my list count. So we have calculated the list count, means we know that what is the list distance that can be measured by this spirometer. Now question arises how to take the measurement. So let's proceed and take the measurement by using this spirometer. So for that you need to draw the table. So let me tell you, the table is exactly similar to the table of screw gauge. So tabulation. The first of all you have to write the serial number or number of observations. Then ICSR, that is your initial circular scale reading, as I have told you earlier also. Then NCR, that is number of complete rotations. FCSR, final circular scale reading. Then I difference F, this is initial circular scale reading minus final circular scale reading. Then your PSR, which is nothing but pitch into number of complete rotations, pitch into NCR. That should be written in centimeter. Then CSR. What is CSR? CSR is nothing but I difference F multiplied into list counts. That is also in centimeter. Then total. Your total is nothing but PSR plus CSR. Obviously this would be in centimeter. Then is your mean. And why we are taking the mean? Because we are going to take at least 10 observations, so that we will commit less number of error or minimum error. So this is the table through which we are going to take the observation. So this is my table, exactly similar to screw gauge. So how to take the readings or observations? So let me tell you how to do it. So you see, this is my watch glass, and the procedure for convex and concave spherical surfaces are different. So first of all, let me tell you how to take the observations in convex spherical surface. This is my convex spherical surface. You keep the watch glass like this, because this one is convex spherical surface. Then take the spirometer and just keep it above. Keep it above. So I am telling you the procedure first, then after that I will tell you the formula. Don't worry about it. I have just omitted the formula part, because that is the formula needs certain understanding. So let me tell you first the procedure, how to take the observations, then I will tell you how to calculate it. Calculate the radius of curvature. So now you see, I have just kept it over the over this watch glass or convex spherical surface. So you give rotations to the circular scale till the middle leg. This one is the middle leg. Till the middle leg, this one is middle leg, touch the top surface of this watch glass or of this convex spherical surface. How you are going to know it, that this is touching or not? What you will do, you have to take a small piece of paper. You take a very small piece of paper like this. This one is a very small piece of paper, and you can check it. Okay, as you can see here, you have to keep the spirometer just above this watch glass or convex spherical surface, such that the middle leg has to touch this upper surface of the watch glass. Now you keep it like this and give rotations to the circular scale. I am giving the rotations, you can see. Now you see, now all the three legs just rotated, start rotating, means the middle leg has touched, somehow it has touched the upper surface. So you just give the back rotation over there and test. Now you see the paper is going in. If the paper is going in, that means the middle one has not touched the upper surface. So give rotations. Now you see all three has started moving, all the three other legs. So you just give the back rotation and check again, I'm giving the back rotations. We want to calculate the exact position where the middle leg is touching the surface. Now it's going in. Just give a slight rotation and the paper will not go in. Now you see the paper is not going in, means this is my exact position. So how you are going to take the reading? Now you just see here, you have to take the reading from the circular scale. You see this is 20 and this A's is my reference. This A's of the main scale is my reference. That A's is coinciding with, here you see this is 20, this is 21. This is coinciding with 21. So 21 is my initial circular scale reading. That has to be kept in mind. So this one is my initial circular scale reading. So where I am going to write then? From in the ICSR column I am going to put 21. So now you see I have taken initial circular scale reading. Then what we have to observe? We have to observe NCR. So number of complete rotations. So take this spirometer and keep it on a flat surface. Now you see I have kept it on a flat surface. So what will happen? You can see here there is a gap in the middle. You see the paper previously it is not going in. Now it is going in. Means there is a gap. So you have to now rotate this circular scale till the middle leg touch the upper surface of this plane. So now I am giving the rotations, and what is my reference point? Reference point is 21, as I have told you earlier. Reference point is 21. So that means I have to rotate in such a manner that I have to simultaneously check how many rotations have been completed till the middle leg touch the plane surface. So now let me do it. So you see I am giving the rotations. So here one rotation is complete. I have just rotated and I have crossed 21. So one rotation has been completed. Then you should not do like this. You have to do it gradually. Since I have to show you, that's why I am just tilting it and showing it to you. So now you see after giving rotation simultaneously also you have to check that whether the middle leg is touching the surface or not. You can see the middle leg is not touching because the paper is going inside. So now give rotations. So one rotation has been completed. Now let me continue. Simultaneously I have to check. Now you see it's not going in. So give back rotations and check again. It's not going in. Means I have exceeded the limit. So this is my exact point where the paper is not going in. Just the exact point. Just the exact point. You see the paper is not going in right now. So then I have to note down again it from the circular scale. So how to note it down? You see the A's is my reference point. This A's of the main scale is my reference point. So I have to note it down from the circular scale. So from the circular scale if I note it down, this is 0. Now this is 1, 2, 3 and 4. Yes, it's 4. So 1, 2, 3 and 4. So which one is my final circular scale reading? My final circular scale reading is 4. So I hope so the procedure is clear. First what I have done, I am just recapitulating. I have kept the watch glass and kept this spirometer just on the top of it. Then I have given the rotations till the middle leg touch the upper surface. And that reading I have taken from the initial circular from the circular scale, which is nothing but the initial circular scale reading. Then I have taken it out and kept it on a plane surface where I have given the rotations to the circular scale till the middle leg touch the plane surface, where simultaneously I have noted down how many complete rotations I have taken, and it's complete rotations, not 1.5. This is not a decimal, this is always a complete number, a whole number you have to write. So I have noted down that 1 complete rotations I have got, and then the middle leg touch the plane surface. Then again I have to take the reading from the circular scale. So if I will write down the reading on this tabulation, so now my serial number is 1. This is the first number of observation. Then the first initial circular scale reading is 21, as I have told you earlier. My NCR, number of complete rotation, is 1, and FCSR is coming out as 4. So this is my observations, and as I have told you earlier also, this ICSR, NCR, FCSR and I difference F are divisions. There is no unit for it. So if the same formula here also applicable, if your I, that is initial circular scale reading, is I is greater than F, then directly subtract, that is I minus F is your I difference F. I difference F value is I minus F. And if I is less than F, then you have to add number of divisions on the circular scale plus I minus F. That is the formula for what? Now I difference F. This is the formula for I difference F. And what is my number of divisions on the circular scale? The number of divisions on the circular scale is 100. So 100 plus I minus F. This is my general formula, as I have told you earlier also. That is also applicable for screw gauge. So now here my I is 21, ICSR is 21, I means ICSR, and F is FCSR. So 21 minus 4 is nothing but equals to 17. So this is I difference F. How to calculate PSR? PSR is nothing but pitch into number of complete rotations. So pitch is nothing but 0.1. Your pitch is 0.1. 0.1 multiplied into 1 will give you same 0.1. So PSR is 0.1. What is my CSR? CSR is I difference F multiplied into list count. So list count is this one, 0.001. So 0.001 multiplied into 17 will give you 0.017. So what is my total? Total is nothing but 0.117. So PSR plus CSR. Likewise, you have to take 10 observations. 10 observations. And then you have to take the average of it, such that we will measure a quantity which is nothing but the height up to which it is raised. So as you can see here, what we have measured here, by taking this average, this mean, we have measured this one. Try to understand this height. You can see that means up to what extent it is curved. That height we have measured, this height. You can see the gap over here also. In the camera, you can see the gap. This one, this gap, we have measured. This one, this gap. This is the mean. So then in the next video, I will tell you how to use this one, this mean value, to calculate the radius of curvature of this watch glass or this spherical surface. I will brief you in my next video. So let me just recapitulate. Suppose we have taken the 10 observations and my mean value has come out as 0.117. So we will continue from here. I am taking this one as my mean. Don't worry about it. You have to take 10 observations and average it. Just for an example, let us assume that my mean is 0.117. So I will continue in the next video, where I will tell you what is the formula for the theory to calculate the radius of curvature, how it is derived, and how you are going to use this height that we have measured here. This mean is nothing but the height h. So thank you everyone. Thank you for watching. Do watch the next video.